Okay, so this is my question. This question was asked in Ace test series. Okay, Ace test series. So the question is number of max heap possible with five different keys is what? So the different keys means the keys are distinct. That is, all the keys are unique. Okay, so let's jump into the solution. So how many max heaps are possible? So there is a recurrence relation for finding the number of max heap. Okay, let's say we have n number of keys. Okay, n number of keys in a max heap. Okay, so if I let's say we have a tree with n number of keys, and if we want to find the number of max heap in a tree with n number of keys, so it is given by the recurrence relation t of n is equal to n minus 1 cl t of l into t of r. So this is the formula. So what is l, what is r? L is number of nodes in left subtree, and r is number of nodes in right subtree. So I have to use this formula for calculating that. Okay, so see one thing, it is let's say for if there is only one key, how many heap is possible? For one key, if only one key is there, so only one heap is possible, right? Only one heap is possible. It can be max heap, it can be min heap, whatever, but I'm considering only the max heap. So from here I get t of 1 is 1. Obviously there is only one max heap that is possible. Now let's say there are two keys. How many max heaps are possible? So let's say there are two keys, 20 and 30. So how many max heap is possible? Only one max heap is possible, which is something like this. You can't do anything else, right? There is only one max heap that is possible, because the biggest element should be in the root part, right? So only one max heap is possible when we have two keys. So from here what I can say is that t of 2 is also 1. Now if I want to ask you, if there are three keys, like let's say there are 30, 20, 10, there are three keys, and if I ask you to find the total number of max heaps for these three keys, so what it will be? Okay, so let's say there are three keys, so how many heaps are possible? Max heap. So one heap is this one. Okay, let me use the recurrence relation for that. So because we can't do this same thing for every possible combination, so it will take a very big amount of time. So let's say if there are three keys, so how many keys are possible? So t of 3 is basically, I have to use this formula, tn equals to n minus 1 cl tl into tr. So let's use this formula, which is n minus 1, so it is 3 minus 1 combination l. So how many nodes will be in the left subtree? For let's say there are three keys, 30, 20 and 10. So the heap should look something like this or something else. So how many nodes will be in the left subtree? There will be only one node, right? So, and in the right subtree there will be also one node. So 3 minus 1 c1 into t of l, right? So t of l is t of 1 into t of right. So right subtree has also one node, so it is 1. So it's basically 2 c1 into t of 1. So what is t of 1? It is 1. And what is t of l? This is obviously t of l, so it is 1, and this is t of right, so that's also 1. So it's basically 2, and obviously there will be two heaps only. So what is the heap? One heap is this one, another heap is this one, right? You can't make any other heap except these two. So two heaps are possible. Now let's see if there are four nodes, so how many heaps are possible? So I have to use this same formula again, n minus 1 cl t of l into t of r. So it's basically 4 minus 1 is 3, 3 c. How many? Let's say if there are four nodes like 40, 30, 20, 10, so how many will be in the left side and how many will be in the right side? Let's draw this: 40, 30, 20, 10. So this and this and this, right? So that's how it will be following the binary fashion. So there will be three nodes in the left subtree and there will be two nodes in the right subtree. So it will be 3c3 into t of 3 into t of 2. So let's see, 3c3 is 1 into What is T of 3? It's 2 into what is T of 2? It's 1. So I get what? I get 2. Now similarly I have to find what if there are 5 nodes, right? So for 5 nodes what I have to do? T of 5, I have to use this recurrence relation, which is n minus 1 CL T of L into T of R, where left and right represents the number of nodes in the left subtree and the right subtree. So for 5 it will be 5 minus 1 C. Let's see how many nodes are in the left subtree. So 5 minus 1 C, 3 nodes will be in the left subtree, into T of 3 into T of R will be 1. So what it is? It is basically 4C3 into what is T of 3. The value of T of 3 is, I have derived it earlier, which is 2, and the value of T of 1 is 1. So it is 2 times 1. So it's 4C3 is 4 into 2 into 1, which is nothing but 8. So 8 is the answer for this question. So the question was asked, a number of max heaps possible with 5 different keys. So answer is 8 different max heaps are possible. Thank you.